Hello, hello. Hello, hello. Anyone there? All right, we're live. Let me send the link. Copy. Okay. Check, check. Say hi in the stream if you can, or send an email. Make sure you can hear me and let me know if there's any problems. We're a little early, so we'll see if other people show up. Um, okay, so today again, I just want to go over the practice test, the Unit 6 practice test, and any questions you might have on that. So we'll go over that. I know there might have been some issues with pulling up the answer key on Blackboard. So I have a copy here. In fact, you know what I'll do? Um, let's see if we can do this. Maybe this will be better. All right, so if you were having trouble opening it on, okay, Carly, thanks for saying hi. Enjoy your other work. Um, in case you were having trouble opening the PDF, there's nothing wrong with the PDF. I just, for some reason, we were having trouble opening it on Blackboard. At least some people were. So I just emailed it to your Google accounts. So maybe you can open it there if you want to follow along. But I'll have it on the screen as well. Um, so, okay. So it's 10 o'clock basically. So let's go ahead and start. So just a couple things just to update you. So I know I had mentioned that Zoom program for meeting and maybe live streaming and stuff. That's really only going to be for teachers and maybe if I have to have like a parent teacher conference or anything. But if we have to do kind of a live stream, we can still do it through YouTube because that's part of Google. But they want us to either do it on Blackboard, Collaborate, or Google Meet. So I'll have to look into that. Another thing is, you know, uh, I haven't been told that I shouldn't do this live stream and go over material, but other teachers have been told not to do it, and I think maybe because they might have been assigning work that wasn't optional or something. Again, everything that we're doing right now is strictly optional, and it's hopefully you use it to your benefit. But we're going to start distance learning not until unless they make a change. And when they announce, they said the superintendent said they're going to make an announcement by the end of this week to let us know more about what the distance learning is going to look like. But from all accounts so far, we're not supposed to start like kind of the distance learning thing where I introduce new instruction and I actually might assign assessments and things like that until after spring break. And I think the way it's going to work is when I do assign an assessment, a test or a quiz or something, it's going to have to be within our normal class time. So like it will go back to the blue-orange calendar. And if you were in second period, then you'll have to take the quiz at like 8:10. You know what I mean? And if you were in eighth period, you're going to have to take the quiz at 1:20. Because at that point, when we get back from spring break, uh, it's not really a competition, but I'll be competing for time with you from your other teachers. And so to, I guess, make it fair, it'll just be like, okay, well, this is when you were assigned the student during this chunk of time. So we'll end up doing kind of our lessons during that time. And then I can also like open up a session like after school or before school or something like that where it can be like a question and answer session. And if you can come, great. And if you can't come, that's, it doesn't matter. But like any new instruction really should be during the class time and an assessment or a test, hopefully to try to stop any chance of cheating will have to be done during class time. And so we'll have to figure out what that's going to look like. Okay. So just a couple things before we go over any questions that are on the practice test, if you had them. And I just want a couple things. I posted a couple things today. So you already have the visible learning objectives. I posted those again, just so you can see them again. But really, the unit. So of this document are my visible learning document for this AP class, for my AP class to you all, right? The units you should be reviewing for the AP exam are units 1 through 4, and then unit number 7, the last unit that we haven't covered yet. Okay, so in the visible learning, these are the objectives that will be tested. Okay, so the objectives in unit 1 through 4, and then so unit 1 was all the structure stuff, periodic trends, a lot of stuff, like a lot of review, atomic structure, molecular structure, dot structures, all that stuff. That was unit 1, periodic table, intermolecular forces, intramolecular forces, ionic compounds, all that stuff. That was unit 1. Unit 2 is stoichiometry, solution stoichiometry, reactions, all that stuff. Unit 3 was thermochemistry and gas laws, kinetic molecular theory, and unit 4 is equilibrium. Okay, not acid-base equilibrium, but equilibrium for just regular reactions, and then also KSP. Okay, so all that's going to be covered on the AP exam this year. The way they're going to administer it to you is still going to be, we're figuring that out, but the units that will be covered are units 1 through 4 on the visible learning document, and then also unit 7, which is the kinetics unit, chemical kinetics. So you might want to start going through those learning objectives too. I'll be introducing unit 7 content here soon. And don't worry if you don't do it now with me, or if I get told I can't do it, then I will also be doing it again after spring break. So I'll reintroduce the content to everyone after spring break, because at that point it'll be mandatory, which it is not right now at all. Okay, and then also it's kind of the lab stuff. So we definitely needed to cover Beer's law. That was the lab that we have those different blue solutions of copper concentrations. That's the Beer's Law lab. So we're going to have to do that kind of virtually, and I'll explain that to you. I actually was able to go back to my classroom yesterday, and so I took some pictures of the solutions so I can show you some of those guys, some of those pictures, and kind of walk you through that lab process. But like, calorimetry, go back and review that lab. So the lab techniques, not all of them are there, but like acid-base titrations, maybe not, but titrations are a part of it. So I don't know. So you might want to start reviewing that stuff. But again, we're going to have some time, and we're going to, especially when we get back from spring break, when we know when the windows of testing are, right? There's going to be 2 windows of testing. I'm guessing early May and late May probably, or something like that. And so we only have one more unit to cover, and it's not really a long unit, and it's not that difficult, to be totally honest about it. So we'll cover that unit, and then we'll start reviewing, and we'll get you prepared for that test. So you can, it's a 45-minute test. Just you got to work fast and just get all the information, and hopefully you'll be prepared. Everyone gets a 5, and we'll have a great summer. Okay. But the other thing I did was, if you recall, we went over, I had the College Board classroom, your AP classroom, open yesterday, and I was showing you their units, the way they model it. Okay. So I took all those topics and I typed them up here. These are all the topics from the College Board classroom, and I put them in this document. I posted this on Blackboard as well. And so the bold unit, this in bold, is the unit where I say it comes from. Okay. And then this is the College Board unit. So my unit 1 it covers College Board Unit 1, College Board Unit 2, some of College Board Unit 3. All right, does everyone follow that? So what I'm doing here is I want you to I'm showing you the topics, and so this is where you would find them in our unit, okay, in our units on the visible learning document. But if you're looking at review material that College Board has made, not the ones that I made, not the concept checks, the unit 6 concept check 1. If it's something that I made, then it matches up with my units, right? But if it's something that College Board made, then it matches up with their units, and they have units 1 through 9. I only have units 1 through 7, okay? So this is the College Board unit. So like if you're looking for practice, that because College Board is putting up review material and stuff like that. If you're looking for practice on our unit 7, which is chemical kinetics, so you're looking for review material, maybe I know there's going to be some AP chemistry teachers, content and stuff that they're going to be putting, they're going to be posting review lessons and stuff that you can get to, that you might want to use. Like if you want to get lessons on chemical kinetics, which is our unit 7, that's College Board unit 5. So when you're in the College Board AP classroom, notice how it says my unit 7 is College Board unit 5. So if you're looking for instruction or practice problems on this stuff, then you need to be and you're in the College Board classroom, you need to be looking for unit 5 review material, not unit 7 review material. Okay, I hope that makes sense. And I hope that's helpful. But this is the stuff that's going to cover it. And unfortunately, our unit 5 and 6 stuff mostly won't be covered on the AP exam, but they're cutting that out this year. Okay. Okay. So, are there any questions about that stuff before we get into the unit 6 practice test? All right, any questions? Okay. So let's go ahead and look at the Unit 6 practice test. I'll pull it up right here. We'll just go one page at a time. Let me know if you have any questions. Um, so so here are the answers. Hopefully you have your copy of the test pulled up, but here are the answers for the first page. It's B, D, C, B, A are the answers to those multiple choice questions. And again, just let me know. Let's just go one page at a time, and then we'll get to the free response. But are there any questions on the first page? Any things that you'd like to go over on the first page? And if I move forward too fast because of the lag and the just post your question and I'll come back to it. We'll make sure we cover it. Okay. Can you explain number 4, multiple choice? Okay. Current is allowed to flow for 5 minutes. Okay, so you don't know how long the battery's going to last, so you can't say that, if you let the battery run for 5 minutes, you don't know if it's going to go to zero or not. Like if it said you let it run for a year, then you could just say the voltage is going to go to zero, right? But for 5 minutes, the voltage is probably just going to keep going, okay? But understand that as soon as the reaction starts, the initial voltage, which would be like if you're at standard conditions, which means 1 molar and 298 Kelvin, right when the reaction starts is when you're going to get your highest voltage. That's going to be your standard potential, and that's going to be the highest value. Because as the reaction proceeds, if you look at the reaction, what are you doing? As you look at the reaction, as the reaction goes, the concentration of silver ions is going to decrease, and the concentration of cadmium ions is going to increase. Okay? So what does that mean? If we go to the Nernst equation, here we go. If we go to the Nernst equation, which is E equals E, let's see if I have it. Yeah, okay. E naught minus RT over NF natural log of Q. What we're doing is, so if you look at the Nernst equation, if you understand the Nernst equation, then you understand that when Q is equal to 1, the potential of the cell is going to equal standard cell potential. That's what this equation is showing you. Sorry if it's too small, right? So when Q is equal to 1, but as the reaction proceeds, right, what is Q equal to in this example? Q is equal to the concentration, the concentration of cadmium 2 plus divided by the concentration of silver plus squared, right? That's what Q is equal to. Q is just the equilibrium constant for the reaction, right? Okay. So what we said is as the reaction proceeds, this value, the cadmium concentration is going to increase. You're going to produce cadmium and you're going to take away silver ions. So that concentration is going to decrease. So Q initially, when potential equals the standard cell potential, Q is equal to 1. Well, why is Q equal to 1? Because this concentration starts out as 1 and this concentration starts out as 1. So 1 over 1 squared equals 1. So Q equals 1. The natural log of 1 is 0. So that means potential equals standard cell potential, right? If you go back to the Nernst equation, okay? Well, what's happening? So as the reaction proceeds, Q increases as the forward reaction runs, right? As the reaction produces voltage, Q increases. And according to the Nernst equation, as Q increases above 1, cell potential decreases. The voltage becomes less and less. Okay. Now, you could use the Nernst equation to justify that answer, but the other way to do it is Le Chatelier's principle. Okay. If you look at Le Chatelier's principle, right, if I have more product and less reactant, I'm going to favor the reverse reaction over the forward reaction. And favoring the reverse of a redox reaction, or I guess a better way to think about it is the forward reaction is becoming less and less favorable. So as favorability decreases, right, that means cell potential also decreases. The more positive the cell potential, the more favored the reaction. So as favorability decreases, so as I decrease the favorability of the forward reaction, I'm decreasing the cell potential. Okay. Does that make sense? Okay. And then let's go to the email. I think I got a question. Okay. Can you go to number 1 and 3 on the free response portion? Yeah, I'll go over those on the free response. Definitely. Okay. Any other questions on the first page though? Let's just go page by page. You know. So go ahead. Just send me your questions and we'll go through it. Like so, like say just in the comments put MC number 10, MC, this free response 1 and 3. So I got requests for free response 1 and 3. Yeah, Trace, the stuff is on Blackboard. The stuff I sent on Blackboard, you were supposed to. Again, this is all optional. We didn't learn this in class. We didn't learn about the Nernst equation in class. Okay, it's on Blackboard. I wanted you to finish the guided notes that you got on electrochemistry, the PowerPoints on Blackboard. Yeah, this is all kind of stuff that we've gone over in the past few live streams. Okay, so again, it's not mandatory, and it's not something that I'm going to be really going over when we get to after spring break when it does become mandatory because the electro stuff isn't going to be on the AP exam this year. So something I want to go over today, but yeah, just okay. Oh, it was during the SOL. There you go, Trace. Yeah. Okay. All right, so we got if cell potential is 0 is the voltage. Yes, cell potential is the voltage. Cell potential is the voltage. Voltage is cell potential. Cell potential is voltage. Okay. Most of the junior. Okay, yeah. Okay. MC number 9. Okay. Okay. MC. So I got MC number 9, MC 15. Let's do those. So let's stick on the multiple choice, and then we'll get to the free response. So MC number 9. Let's see. Okay. So this one's kind of a weird question, but I'll understand that this is just a half reaction. How do I know, looking at this is just a half reaction? Because the electrons are there, right? Only on one side of the reaction, right? If it was an overall redox reaction, you would have electrons canceled out. Okay, electrons would be canceled out. You wouldn't have electrons there, right? And if it was an unbalanced overall redox reaction, then you would have electrons on both sides of the reaction, right? Does it make sense? Okay, but this, I only have one. So when you have electrons, so first off, just understand, it's a half reaction. We have a half reaction. That's it, okay? And it's a reduction half reaction because electrons are on the reactant side, okay? If electrons were over here, this would be an oxidation half reaction. So just a couple things. Reduction, electrons are required. Okay, so something's being reduced in here. Okay, and that's all it's showing. It's just showing a reduction half reaction. And remember, reduction occurs at the cathode. Okay, so whatever's being reduced, it gets reduced at the cathode. Okay, and how do I know there's a cathode and anode? Because it says an electrolytic cell. That's a cell. That's another name for a battery, another name for a galvanic cell, another name for a voltaic cell. It's the same thing, okay? So this reaction doesn't tell me anything's being oxidized. So B can't be the answer, right? Aluminum is converted from -3 to 0. No. It's actually aluminum is +3 and the fluoride is -1. Okay, so that's not right. F minus acts as the reducing agent. No, F minus is just nothing. F minus isn't oxidized or reduced. It's F minus over here and it's F minus over here. Okay, remember, whatever got oxidized, we don't see because we only are seeing the reduction half reaction. F minus is reduced at the cathode. No, F minus didn't change. It was F minus over here and it's F minus over here. So that leaves us A, and that's what it's saying. It's saying this is reduced at the cathode. Now, technically it's aluminum, just aluminum being reduced at the cathode, but your source of aluminum is this complex ion of AlF6 3-. Okay, so hopefully that answers the question. So multiple choice number 9. Let's go multiple choice 15. All right, so balancing a redox reaction in an acidic solution. Well, how do I know it's in an acidic solution? H plus. They kind of give you a clue there, okay? Remember, use the half reaction method, okay? If you're balancing this, use the half reaction method. Now, you might want to try to guess and check because they do give you the H plus and you get the water. And so you might want to try to balance this by just going back and forth and getting the right numbers. But when most people do that and they don't do the half reaction method, they get 8 in front of H plus and they choose letter C. Okay? Well, 8 is the balanced hydrogen for this half reaction, but when I add the two reactions together, I gotta multiply the reduction reaction by 2 and the oxidation reduction by 5 because I need total electrons to cancel out. And this half reaction has 5 electrons. This half reaction has 2 electrons. Okay? So what does that mean? It means in order to add these two together to get my overall balanced equation, which is what I'm looking for, electrons have to cancel out. So I got to multiply this one by 5 and this one by 2. And so when I multiply this one by 2, I get 2 times 8 H pluses, so I get 16. Okay, so we had to use the half reaction method. So how did I do that? Okay, so I had the oxalate ion, right? C2O4 2-. I'll update the format here in a second. Yields CO2. That was the oxidation half. How do I know it was oxidation? Because, well, okay, so if we assign oxidation states, okay. So if we assign oxidation states, the carbon in the oxalate ion, so has an oxidation state, well, let's see, -2 for the oxygen, that's -8. So that means the carbon has to be +6, and you have 2 of them. So the carbon is +3. So the carbon is going from +3 to +4. Okay, it's +3 in the oxalate ion, and it's +4 in CO2. So that's the oxidation half reaction. And so, and then so the reduction half reaction was the manganese. So we had permanganate minus yields manganese 2+. So we had manganese or permanganate going to manganese 2+. Okay. Okay. So the manganese, this is the reduction half reaction because the Mn is going from +7 to +2. Okay, so that's the reduction. Okay, so now let's do our rules. How do we balance oxidation reduction reactions using our half reaction methods in an acidic solution? Well, first thing, you got to balance everything that's not hydrogen or oxygen. So I got to put a 2 here in front of the CO2 to get 2 carbons. Okay, the manganese is balanced. Then I would go and balance oxygen by adding water. Well, I got 4 oxygens here, and now because I put that 2 there, I got 4 oxygens there. So I don't need water in this one. But I have 4 oxygens here, so I'm going to have to add 4 H2Os to this equation. But because I added 4 H2Os there, I got to come back over to this side and add 8 H pluses. Right? So that's where the 8 H pluses come from. Okay. So now everything's balanced except for charge. Now I got to balance the charge. I got a 2- charge on this side, so I got to add +2 electrons, right? And then if I come up here, I have a total of +8 and a minus. So that's +7 on this side, and I got +2 on this side. So I have to add 5 electrons to this equation. And so again, I get this half reaction is balanced. This half reaction is balanced. But for these two reactions to combine, electrons have to cancel. So that's why I have to multiply this reaction by 5, right? And I have to multiply this reaction by 2. So when I do that, the electrons will cancel, but I'll end up with 2 times 8 H pluses, not 8. So 16 H pluses, not 8. Okay. So hopefully that helped you there. Remember, we did balancing redox reactions in an acidic or basic solution way back in Unit 2, at the end of Unit 2. So if you want to, go back and review those rules, look for the Unit 2. And there was a handout of notes that I handed out back then too. And it'll be on Blackboard, but if you go back to the Unit 2 material stuff too. So you might want to check that out, okay? All right. And again, okay, so I got some more. So we're going to go, so we just did 15, and we're going to do 17, but I'm going to go back, and I got questions for a few others. So let's go. So we're going to go to number 10. All right, so number 10, what we had to understand is, okay, so we were given the overall potential for this redox reaction, and we were given the reduction potential for silver, but it was asking for the reduction potential for Mn3+. But if we look at the overall reaction, right, Mn3+ isn't being reduced, it's being oxidized, right? So remember, E-ox plus E-red, okay? So for this one, right, E-cell equals E-ox plus E-red, right? Well, we got the cell potential, right? We got the cell potential. The overall cell potential is what, 2, so we got 2.46 equals E-ox, which is our unknown, plus E-red, because the silver was being oxidized, right? So the silver was being reduced. So that plus 0.8 is E-red, because silver is what's being reduced in that reaction. So we get 0.80, right? So we get E-ox, right? We get E-ox for the manganese. Was it manganese? Just metal M, okay? So whatever. Equals 1.66 volts. But that's oxidation. That's for this reaction. M yields M3 plus 3 electrons. That's for that reaction, right? That's the voltage for that reaction, but we don't want the voltage for the oxidation reaction. We want the voltage for the reduction reaction. So what do we have to do? We have to reverse the reaction, and so we flip the sign. So it comes out to be 1.66. Okay? So that's kind of the tough one. Okay? Okay. And then, okay, so we got multiple choice 10. Let's go to number 11 as well. Okay. So of which of the following reactions which involves the largest decrease in entropy? Okay, so first of all, let's cancel out A and D. A and D are increases in entropy because, right, A, you got a solid going to a solid and a gas. D, you have, if you balance it, there would be a 5 in front of here. So you have 6 moles of gas going to 7 moles of gas, right? So 1 plus 5, 6 moles of gas going to 7 moles of gas. So that's an increase. This one we have a decrease, but it's not a huge decrease because everything's still a gas, right? So we have 3 moles of gas going to 2 moles of gas. So that's a decrease, but it's not a huge decrease, right? Here we got all aqueous, and then over here we got 1 aqueous and 1 solid. So that's going to be a decrease in entropy, but we have aqueous to solid. Aqueous isn't as disordered as gas, right? Okay? And then if we look at this one, if we look at E, we have a solid, but we have 3 moles of gas, and now we have 0 moles of gas, and everything's a solid. So that's going to be the largest decrease in entropy, okay? You go from 3 moles of gas to all solid, all right? That's going to be the biggest decrease in entropy, okay? And then, so let me just check and make sure no questions, okay? And again, jump in like if I don't completely satisfy answer you with a satisfy reply, like if my answer isn't satisfying you, go ahead and ask again or ask me to elaborate. So also we're going to go to number 12, and don't worry, I'm going to come back to 17. Okay, so let's go to number 12. All right. So number 12, the reaction indicated above is thermodynamically spontaneous at 298. Okay, so boom, right away, we know delta G is negative. Okay, we know delta G is negative. It says it's spontaneous at 298. So before I even read the rest of the question, before I even read it, I'm going to say, well, it can't be A. So it can't be A. All right, so now it says, but it becomes non-spontaneous at higher temperatures. Well, what does that mean? That must mean it's exothermic, right? Because endothermic reactions become more spontaneous at higher reactions. Heat must be a product. So what does that mean? It means delta H is negative because it's an exothermic reaction. So I know delta G and delta H are negative, okay? So it can't be A, it can't be D, and it can't be E. All right, so that leaves, what does that leave? It leaves B and it leaves C, right? But remember, like, I mean, we can look at the reaction when we're going from 4 moles of gas to 2 moles of gas, so delta S is also negative. But remember, that's the case for a negative combination, right? If you go to your delta G equation, right? Go to your delta G chart too, right? Your spontaneous chart, right? So when we look at this, we look at delta G equals delta H minus T delta S. Remember what we said is anytime you have a negative delta H and negative delta S combo, reaction becomes less favored at higher temperatures. Right? That's go back and look at that thermodynamic chart where it's like delta G, like when this is your combination of delta H, delta S, these are the temperatures when you're favored, these are the temperatures when you're not favored, that kind of thing. You have that memorized, right? So that means delta S is negative, delta H is negative, delta G is negative. They're all negative, so that's why it's choice B. Okay. Let's see. Let's keep going. What was the other one? So that was 12. Let's go 14. I also got a 14. Okay. This one's tricky. Number 14. Equation 3 wasn't balanced. It wasn't balanced. So when you balance it, you go from 6 moles of gas to 3 moles of gas. So that's a decrease. That's a decrease in entropy. That's a trick question. That was actually a question on the AP exam. It was a long time. It was before 2013 because this was a question. How do I know? Because the new AP exam only has choices A through D. The old AP exam has choices A through E. But this is a decrease in entropy because it wasn't balanced. You had to check yourself there. That's, I feel that's kind of dirty because they put that 3 there. So, anytime you see a coefficient other than 1, you say, well, they balanced it for me. Well, not in this case. They were kind of mean about it. So anyway, it wasn't balanced. But once you balance that reaction, you'll see that there's a decrease in entropy. So it was these two that decreased in entropy. So it was 2 and 3. Okay. And then, so let's go to 17 and then we'll go to 19. And then if there's any others, now's your time to put in the chat or email me, or we're going to just go to the free response. Okay. All right, 17, 17, 17, 17, 17. All right, so given the above standard, approximate the value of the equilibrium constant. Okay, so this is just using our equations, right? If I can, so again, these are equations are in your formula sheet. So you know, if I know delta G, so if I know cell potential, I can calculate delta G, and if I can calculate delta G, I can calculate the equilibrium constant, right? So you could just plug it. So you have to figure out your cell potential. So this is the reaction I would flip, right? This is the one I would flip because that's the most negative one. So that means it becomes the most positive, and this is my voltage, right? So I flip this reaction, add the two together, so it's 0.4 plus negative 0.28. That's the voltage, so that's the standard cell potential. So what I could do is plug it into my delta G equation here. Moles of electrons being transferred, it's 2, right? In the balanced equation. And F is Faraday's constant. So that would give me delta G, and that would be joules, all right? And then what I could do is plug in my delta G and solve for K. Well, if I solve for K, it's K equals E raised to the delta G over negative RT. But what I did was I combined those two equations together. So you get, what you would get is E raised to the negative 2 times Faraday's constant times the cell potential, which is 0.12, over negative 8.314 times 298. And when you do that, you get close to 11,000. It's around 11,000. And so it's 10 to the fourth. Now you should immediately cancel out A and B because cell potential is positive. That means equilibrium constant is greater than 1. And then so it's just like, which one is it? Is it 10 to the fourth or 10 to the 16th? Okay? So hopefully that helps. But again, those equations are on the formula sheet. And then let's go to number 19. Number 19 here. Okay. All right, bonds broken minus bonds formed. Okay, bonds broken minus bonds formed. Reactant bonds minus products bonds. Okay, so 2 times 436. Why did I do that? Because I have 2 hydrogen-hydrogen bonds. How do I know I have 2 hydrogen-hydrogen bonds? Because of the coefficient. So it's 2 times those bonds. Plus 1 oxygen-oxygen double bond, 499. Okay, so it's whatever that is, minus, now it's the bonds over products. I have 2 water molecules, but in one water molecule, there's 2 H bonds, HO bonds, right? So 2 of those molecules would have 4 of those bonds. So that's why it's 4 times 464. Okay, and so it's just that minus that. Bonds broken minus bonds formed gives you the delta H of the reaction. Okay. All right. Any other questions with multiple choices before we go to free response? And I already got free response 1 and 3. Are there like, so Charlie, do you want me to go like through all of number 1 or in all of number 3 or just specific parts? We can do that. All right, all right, so let me know. So I got requests for 1 and 3. Any others, or like the whole thing, or what would you all prefer? Questions? Okay. All right. Well, let's dive into it. Number 1. All right. So a galvanic cell is made with a cadmium electrode and a silver electrode. They're both 1 molar solutions of cadmium and silver, so you know you're at standard conditions at 25 degrees Celsius, so you're at standard conditions, so you can use your standard cell potentials. All right, they gave us the reduction potentials, all right? So I'm going to have to flip the cadmium one because that's going to give me the positive cell potential, right? If I flip this one, if I flip the silver, um, then I would end up with a negative zero point 0.8 plus a negative zero point 0.4, and that would give me a negative voltage, and that's not a spontaneous reaction. Okay, does that make sense? So it's got to be you always flip for spontaneous reaction. You always flip the reduction potential that's the lowest one. Okay, so because that ensures a positive cell potential. Okay, okay. So just 1A. Okay, so you have to flip that one to ensure the positive potential. And then so when we get our balance, so we flip that reaction, right? We flip that reaction, and then to add up the two reactions, we have to get electrons to cancel out. So I got to multiply the silver one by 2. Now remember, when you multiply the silver by 2 to get number of electrons to be equal to each other, so they end up canceling out, right? You don't change the potential, right? The voltage is still the voltage. Okay, you don't. That doesn't change when you multiply. Okay, so this becomes a positive zero point 0.4. So positive zero point 0.4 plus positive 0.8 gives me my voltage for 1B. But I had to double the silver to balance the equation to cancel out the electrons. And so this would be the balanced reaction when I add everything up, right? So I would have 2 silver ions on this side and 2 silvers on this side, 1 neutral cadmium on this side, and 1 cadmium 2 plus on that side. Okay? Okay. All right. So once we get that, we get the overall potential. This is what, essentially our battery needs to have. Now, a couple questions, you could be asked about later on is like, what electrode, what happens to the cadmium electrode over time? And so the cadmium electrode is going to lose mass, right? And the silver electrode is going to gain mass over time because silver ions would be plating on to the silver at the cathode, but cadmium atoms will be dissolving into solution as cadmium 2 plus ions as they push electrons away from them. Okay. Um, and then, how do you guys feel good about part F? You guys feel okay about part F? Using the Nernst equation. You can also use Le Chatelier's principle, right? You could say decreasing the concentration of silver, decreasing the concentration of a reactant favors the reverse reaction, so cell potential goes down. Okay, decreasing the concentration of a product favors the forward reaction, right? If I remove some cadmium ions, that's going to drive the reaction this way. So that's going to increase the favorability of the forward reaction. So cell potential would increase, right, for part 2. But you can also use the Nernst equation. So for me, it's just easier to just say Q is greater than 1, so cell potential decreases. Q is less than 1, so cell potential is increased. But that's because I got the Nernst equation in my head, right? You guys, we didn't have class with the Nernst equation, unfortunately. So, either you get the Nernst equation or you don't. You go back and you can learn about it and figure it out. But it's just, I think it's a lot easier to invoke the Nernst equation. It becomes more wordy when you're explaining in terms of Le Chatelier's principle. But it's a lot it's easy to say, oh, cell potential decreases because Q is greater than 1. All right. So all of them. Well, let's pull it up. Right. Right. You guys should have a copy of the formula sheet, right? You can check, but let's check it. The Nernst equation isn't. I guess that's an important thing. The Nernst equation is not. Did I have it? There we go. All right, formula sheet. It's all the delta G equations are on there. Right. If you look at thermo, right? Look, you got all these, right? You got delta G, well, you got delta G products minus reactants. You got delta G equals delta H minus T delta S. You got delta G equals negative RT natural log of K. And you got delta G equals negative NF cell potential, right? So you got those ones, the ones that you need. But you don't, again, you don't get the Nernst equation. Just, so it would be, if you want to invoke the Nernst equation, if you're asked a question like that, you would have to have it memorized, or just understand the Q part of it. Don't even write down the Nernst equation, because they would understand what you meant if you said, "Oh, Q is greater than 1, so cell potential decreases." But remember, also another thing to remember, delta G and electro equilibrium is going to be on your AP exam, but this year your AP exam is not going to include the electro stuff, so you're not going to even have to think about invoking the Nernst equation on the AP exam. Okay, maybe the final exam, but we'll cross that bridge when we get to that bridge. I don't have no idea what's going to go on with final exams and that kind of thing. All right, let's not even worry about it. Right now, I think our number one goal after we get through the this practice test, your number one goal should be let's prep for the AP exam, and then after that we'll figure out what we need to be, Okay. Okay, so Maddie said 2C. All right, so 2C is just percent yield, and percent yield is actual yield over theoretical times 100. So you might, a lot of people get to this question and do percent error. And remember, percent error is the difference between the two values divided by the true value times 100. So the difference between experimental and theoretical, the absolute value of that difference divided by theoretical times 100. That's percent error. Percent yield is just actual yield, your experimental yield, what was actually produced, divided by theoretical times 100. And one thing to note is that if you do 100 minus percent error, that gives you percent yield. So percent yield plus percent error equals 100% always. Okay, because like if you only got 72% of what you should, then that means you're 28% in error, right? Okay, so they gave us our actual yield, and in a question, actual yield, experimental yield has to be given to you. Like in a test question, they have to say, this is what the student got. Okay, that's the actual yield. And then the theoretical yield is the stoichiometric yield. So they said they did an 8 amps for 15 minutes, and they got 1 gram of solid. Well, we did this calculation here to get how much grams of solid we should get. If all the electrons went to reducing the metal, then this is the mass of metal we should have gotten. And then so theoretical yield is just actual divided by, percent yield is actual divided by theoretical times 100. Okay. Okay. Any other questions with number 2? All right, guys, number 3 on the test is kind of, I think it's like so easy that you guys can't believe that it could be that easy or something like that. Like, so the reaction's spontaneous, right? They tell us delta G is negative, the reaction's spontaneous, so that means products are favored. So, and sometimes it's the word predominate. Like I've had students in the past when I give this test actually come up and ask, what that word means. So predominate means what do you have most of in the flask? And so when the reaction reaches equilibrium, well, the equilibrium constant is greater than 1 because delta G is negative. So for number 3A, it's just the products. Whatever the products are going to be the most predominant thing. And then if you had a product if you had two different products and one had a coefficient of 1, but the other had a coefficient of 3, you would have the product that has the higher coefficient because you get 3 of those for every one of the other product or something like that. But in this case, you only have one product. So it's just the product. So this is what you're going to have more of. How do I know? Because delta G was negative. That means KEQ is greater than 1. That means I have more products than reactants. Okay, does that make sense? So part B, we know it's an exothermic reaction, right? Because delta H was negative. So that means so one way to think about it is heat is a product. So if heat's a product, as you increase the temperature, you're going to shift the reaction towards the reactants. So at higher temperatures, you're going to favor reactants and not products. So the equilibrium constant is going to decrease, which means the reaction is becoming less spontaneous, right? Does that make sense? So for exothermic reactions, reaction becomes less spontaneous as temperature increases. For endothermic reactions, the reaction becomes more spontaneous, more favorable as temperature increases. Okay. So that was number 3. Hopefully that helps. But that's really all you needed, you know. And that's the thing, like, you know, as we start to think about what the AP exam is going to look like, it's only a 45-minute test. I think there are going to be a lot of questions, and you're just going to have to answer quick. You know, I think it's going to be there might be one question that's like a 10-minute, like 10 to 15-minute, like part A, part B, part C, full long. But then I think there's going to be some other questions which are just like boom, 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 because I think they're going to want to test you on a lot of stuff, but you only have 45 minutes to do it. Okay, but we'll see. They're going to give us an example on April 3rd. Okay, were there any other questions? I know we did question 4 already, like in class together. And then question 5. Question 5, if you had trouble with question 5, it's because I didn't give you the potentials. Like, understand that for this question, you would be given the reduction potentials you need. This question was a really old question, and on the old question, on the old test, part of your on the old test, you got a periodic table, you got your formula sheet, and the formula sheet used to have the Nernst equation and stuff like that. But then you also got a list of reduction potentials. You also had like an appendix E was also given to you for the actual AP exam. So when this question was asked on the AP exam a long time ago, it was understood that you had the reduction potential list with you. So now they don't give you that list anymore. So that means anytime you need reduction potentials, they have to be given to you within the question. So you had to reference Appendix E to answer this question. But hopefully once you got that, it's not that difficult once you understand you have to reference Appendix E. Okay. There any other questions with the practice tests? Anything you want to go over? Anything at all? Any questions? Email me if you have them. Post them in the chat. Hopefully that answered some of them. Hopefully you guys are getting by pretty well. Seniors, sorry. Sorry your year got cut short like that. So tomorrow, I think I'm going to post some stuff tomorrow, but I don't think we're going to do a live chat. In our meeting this morning, it's kind of I'm being discouraged from doing new material. So maybe if you guys want to start reviewing on your own of past material, I can get on and maybe if you want to go through your old, if you want to go over the visible learning objectives and stuff like that, we could do it. But I don't know. We can start getting into kinetics, but I think it's like other teachers have posted stuff, and they've been told by their administrator directly to stop doing it. I haven't been told by my administrator to stop doing this, so that's why I think I'm still doing it because I don't find harm in it. But if I do get notified by my administrator to stop, then we'll have to stop and wait until after spring break, so like April 14th or something like that. But I'd like to keep doing this, but I don't know if tomorrow I'm going to just start heavy in on chemical kinetics, which is our last unit. I might post some stuff if you want to start getting into it for yourself, but maybe we can have a live stream chat on questions that you want to like review stuff, because we kind of have to go back and review equilibrium, review gas laws, review all the periodic table stuff. I have a feeling it's going to be heavy, like periodic table, intermolecular forces, that kind of thing, because. And I want to go over mass spectroscopy charts and PES charts and stuff like that. But I also want to do that with everybody else too. So, I know a lot of people aren't, watching these, whether they're watching them live or later. And so, I get kind of concerned about all the students that aren't here. What are they doing? Are they trying to keep up? That kind of thing. So hopefully we'll make it mandatory at the end of spring break. I was hoping to do it a little bit earlier than that, but yeah, I'll post all the materials tomorrow, and I still kind of want to do it. So I'm going to post the guided notes and the PowerPoints and stuff tomorrow, and I think I'll still live stream and go through the PowerPoint with you guys. It's not that long. It's a couple of PowerPoints and then a couple practice problems we can do together, and then we can post that and stuff. So we'll see. I'll post and I'll let you know if I'm going to live stream or not. But yeah, I'll post that stuff tomorrow. Okay. But also remember the College Board. The AP Classroom, they have a lot of review material up there as well. So you might want to start looking at that stuff too. Okay? Any questions before I go? Okay. Yeah, I'll post all the Unit 7 stuff, which is, again, our Unit 7, College Board Unit 5. Okay, that's what you want to look at. So like if you're trying to learn some of that new stuff, College Board Unit 5, look for that kind of stuff. Okay, and it's just kinetics. It's rate laws, kinetics. Look up, just go to Khan Academy and look up, what's a rate law. And remember, go look at this. These are the different concepts. Right, it's our Unit 7. So if you want to look at our visible learning objectives, here's all the stuff that you need to be able to do. Start Googling that stuff. It's also, I think it's, shoot, I don't have a textbook on me right now. It's upstairs, but I think it's chapter 13 in your book. But just look up chemical kinetics in your book. Look it up in the, start reading that chapter. The book's got a lot of good stuff. Start reading that chapter, and we'll go over that stuff next time. But then also, these are the topics based on College Board. So it's this, right? These concepts, reaction rates, rate law, that. So it's that stuff right there. That's the new stuff. That's the stuff we haven't talked about yet. That's the stuff we haven't touched. Everything else we've touched. It's just going back and reviewing. Okay. Okay. So anyway, yeah, I'll post that stuff tomorrow. Maybe I'll post it and then I'll come in. Maybe we'll come in on Friday, and I'll try to teach it to you guys too. I don't know. I don't know. It's just the kind of vibes that are put out. It's like hey, you shouldn't be teaching new content. And I don't understand why, but I haven't heard a good reason yet. But you know, so we'll do it until I guess I get complaints from you know parents and stuff. All right, so yeah, that's it. That's all I got for you. I'll post the new stuff tomorrow. Feel free to email me any questions that you have later on. Okay. Have a good day.